Do I care that you know if it's product property number 1? No. What I do care about is if you can do the math that's related to it. So, what that one says, if I have 2 to the second times 2 to the third, what do I do with those exponents? Add the exponents, definitely. Exactly, they have the same base, so I can add the exponents. So this right here now becomes 2 to the power of 5.
Okay, don't let this tip over.
So that's product property number 1. Okay, the next one said, if I had, and it's a quotient property, and it tells me is if I have the same base, let's say I had 2 to the 4 over 2 squared, what do I do to the exponents? I subtract the exponents. So my new would be 2, 4 minus 2, which would be 2 to the power of 2. Okay? So those are 2 of our properties, right? Okay? The third property that we talked about is the one to me that is probably the trickiest one in your mind. So let's talk a little bit more about that one. And that is the negative exponents property. I say in your mind because
it doesn't make sense.
When you think of a negative, you don't typically flip things, right? You change the sign. But a negative exponent has nothing to do with positive or negative answer. Okay? So when you see a negative exponent, if I had 5 to the negative 5, what I need to think is flip the base and keep the exponent. That's all that negative sign means. So this then becomes 5 to the 5th on the bottom. You guys have to tell me when you can't see because I'm not very good at moving things up on time. Or if I had 3 halves to a negative 6, this then becomes, I flip this, so I now have 2/3 to the 6th.
What do you do if there's a negative in front of the big 5?
So if this was negative 5 to the negative 5th, okay, but Amanda says if I have negative 5 to the negative 5th, I'm going to still flip this part right here, okay? So now I'm going to have 1 over negative 5, keep the base, or keep the exponent, so I would have 1 over negative 5 to the 5th. When I put this in my calculator, I would keep negative 5 in parentheses. But yesterday, I wrote this up on the board. We didn't get to really talk about it. If you have an even exponent, you're going to have a positive answer. If you have an odd exponent, you're going to get a negative answer when there's that negative number in there. But if you put it in your calculator just like this in parentheses, it will do it for you. Okay? Is everybody comfortable with that negative exponent now? Okay, let's talk about 0 exponent, which I probably don't even need to talk about, right?
I thought that every time you do it, it makes everything 0.
No, it makes it
1. Yeah, well, I got that wrong. Every single time I did it.
any number to the power of 0 gives you a 1. So I could have 3,000 to the power of 0, and it's going to be a 1. I have a gazillion to the power of 0, it gives me a 1. Okay. Just a couple more. So we've had 1, 2, 3, 4. We're going to do 7 of these. You're going to want these for the thinking math we're going to do today. Okay? So the next one is power property. And the power property says, if I have a number to a power, and another number to a power, I'm going to take these exponents and multiply them. So my new answer would be 5 to the power of 2 times 3, or 5 to the power of 6. As long as there's these parentheses, that tells me to do that. Okay, so you have to multiply the exponents. But remember, if it was listed like this, 5 to the power of 2 times 5 to the power of 3, what do I do with the exponents there? I added the exponents. If I have it like this though, then I multiply the exponents. Okay, there's also one more quotient property. And this one says, if I have 5 over 2 to the power of 3, it tells me that this 3 is distributed to both the 5 and the 2. So really that problem then says 5 to the third over 2 to the third. And this is going to become important as we're starting to solve things algebraically, that 3, or whatever your exponent is applied to both. Any questions on those 7 properties of the exponents?
No. I was just clearing my throat.
Are you still writing up there, or can I move it for now? No? Yes? Okay. Alright, I also want to review just a couple more things with you so that your worksheet is not quite as difficult. So let's talk about power function versus exponential function. And this is not really new, but it's the first time I put it into words for you.
Wait, this is new notes?
It's not really new, it's just the first time that we've put it into words together to compare them. So power function versus exponential function. Okay. A power function has a number as an exponent. An exponential function has a variable, or typically an x, as the exponent. And the reason I go over this is because on today's worksheet, the very first section on the back side on page 29 says, is this a power function or is this an exponential function? And I had a feeling that you're going to turn that worksheet over and at every single one you're going to raise your hand and say, I don't know how to do this. So, if there's a number as the exponent, it's a power function. If it has a variable or an x as the exponent, it's an exponential function. Okay? Alright, one last review, and that's to talk about roots and radicals. Okay? Remember, radicals is that, the root sign, right? Okay. If I had this number right here, a 2 down in this little crack, and 6 to the third, how would I rewrite this? 6 to the power of what? 6 to the power of, what did Mrs. Rumsey say yesterday that made me giggle about this 2 in the crack? The crack is on the bottom. right? Alex, it's funny, isn't it? So whatever number is in your crack, Alex, goes on the bottom. So, 2, and then the top number is a 3. So we would put this in our calculator as 6 to the power of parenthesis 3 divided by 2 to get our answer. What if I had that and there's no number in my exponent right here? What does that stand then? What would be here and we just don't see it? 0. A 1. So this would be 7 to the power of 1, and the number in the crack is on the bottom. So it would be 7 to the power of 1/5. Okay. What if I had something that looked like this, where I had the 4th root of c to the power of 3 equals 29. And I'm trying to solve for c. That looks really complicated, doesn't it? But we know if we're trying to get rid of something algebraically, we have to do the opposite, right? So if I was multiplying, the opposite would be divide. Well, what's the opposite of taking the 4th root of c cubed? In my head, or me, I like to rewrite it. So I'm going to rewrite this as c to the power of 3 over 4.
That was nasty.
Stop touching bugs. Because the 4 is in the crack, it goes on the bottom. So really it's c to the power of 3/4, right? Equals 29. Now, does that look a little bit more manageable? How am I going to solve that? What do you think? Say that again? Okay, but so I have to multiply both sides to the power of the reciprocal of this. And the reciprocal is just flipped upside down. So I'm going to put this to the power of 4/3, and then this has to be the power of 4/3. This, remember we talked about yesterday, canceled that out. Those exponents have canceled each other out. We are left with a c equals 29 to the power of 4/3. Which, someone grab your calculator and give me an approximate answer, please.
2, 3, 5, 7, 6.
2 point,
No.
sorry, it will be a bigger number. 2,
3, 5, 7, 16.
thank you.
3.
0.3?
Yeah.
Is it end at 0.3 or is there up to 3 decimal places?
I don't think that's,
Nope, that's not what everybody else got?
no.
Okay?
Okay.
Did you put it in your calculator with the parentheses?
No, I didn't.
You want us to put in parentheses?
I got the 4/3 has to be in
Yeah, then
parentheses.
it's
Yep.
89.9.
89.9, yep.
Oh, 19.
Okay, remember guys, that was an important lesson. When you put this in your calculator, you're going to go 29, the power button, and then you have to put that 4/3 into parentheses. Otherwise, your calculator reads it as 29 to the power of 4, then divided by 3. So you have to put it in this way. Okay? Otherwise, your calculator calculates it differently based on rules of order of operations. So you should have got 89.097187794. And how many decimal places are we rounding to now? 3. So 1, 2, 3. Cut it off. 89.097. Okay. Are you feeling more comfortable with this now that we've done this as a review?
Yes.
Yes. Okay. Let me just take a quick peek here and see if there's anything else I'd like to remind you of. On the worksheet that we're going to do today, There's also one that looks like this, so I'd like to go over this with you real quick so that you can get a good feel for it. It looks something like this. 1 over the square root of x equals 0.88. Really? It's my son Jack's favorite number. You'll have to make him. He would like it.
Is it negative 88 or something?
So, when I look at this, it looks pretty complicated and confusing and makes me want to shut down and not do it. But that's not an option. So let's talk about what this really means right here. What does this really mean? This is 1 over x, and this is a 2 in here because it's a square root, right? Right? Okay, so x to the 1/2. 1 over x to the power of 1/2 equals 0.88. So, how could I get rid of that? Really, this whole thing is x to the power of negative 1/2. How do I know that? Or sorry, x to the power of negative 1/2. How do I know it's x to the power of negative 1/2? Because it's under the fraction bar. So now if I have this, x equals negative 1/2 equals 0.88, I would just multiply both sides by the reciprocal, negative 2, or negative 2 over 1. And so I'm going to have x equals 0.88 to the power of, parentheses, negative 2, and I get 1.291322314, which I'm going to round to 1.291. Oh, yeah, my bad. Did anybody else hit that same answer? I always like to double check. Thank you. There's one last piece on the worksheet that you're going to look at, and you're going to have to dig back just a tiny bit. So we just finished up in chapter 4, transformations and translations, right? So remember we had the parabola, and to move it up or down, we had to mess with the k, right? Positive k up, negative k down. And if we wanted to move left or right, you had to do the h, right? Minus an h to the right, plus an h to the left, right? They're going to give you a graph of a power. Maybe it looks like this. And you're going to have to say whether it's moved up or down or left or right and write the equation for it. So they're going to give you the base function, and then you're going to apply the same rules that we did from chapter 4. Maybe plus 2, moved it up 2. Minus 3, down 3. Okay, so it's not anything new, it's just applying what we've already learned. Any questions on that?
No.
Okay. So those notes will help with the worksheet. After you're done with the worksheet, you're going to make us a thinking map. And I will leave this up on the board so that you have an example. But you're going to make your own, you're going to use markers, or I want it colorful. But the format of this is what you need to know. You're going to have in the middle properties of exponents. You're going to have 7 shapes around in the inner circle and 7 around on the outer circle. So you know those notes we just went over where I said there was 7 properties of exponents we did?
Yes.
Those 7 I listed again. 1 in each box. Okay. So perhaps in my first box I would write, I'm going to start with product number 1. So in here I'm going to write to myself product number 1. And then how you use the rest of this is up to you. Sorry, my purple didn't show up very well there. We want this to help you. So I prefer words, right? I'm a pretty wordy person. So on my example, I took and said, okay, this is product property number 1. And down here I put my the rule, which was like a to the second times a to the third. And then up here is where I put in words and said to myself, oh, I need to add the exponents. However, up there, maybe you're more of a visual person, and you're going to take, and maybe you would write out an example or two examples. Okay, so we want you to take the notes, and we want you to make them work for you to help you remember those rules. Is there any question on what we're looking for on the thinking map? Okay, so you have two things to do today. You're going to start with the worksheet. I'm going to pass that out. There's two sides to it. You're going to move on to the thinking map, and then we'll get the rest of that moving on for you as well. Okay? All right, Ms. McKinley, you can stop or videotape if you'd like.